Hey guys, so today I'm going to be showing you guys how to solve banked curve problems without friction, and in order to do so I have a problem to show you guys, and I will solve the problem for you guys using the concepts of banked curve problems. So first we're going to read the question. So the question given to us is that a 3,500-pound car is traveling on a banked curve, and the radius of the curve is 120 meters. And the curve we know is banked 6 degrees from the horizontal. And we are asked what is the speed in miles per hour the car needs to travel to not fall off the curve if no friction is acted on the car. So in order to solve this problem, we gotta break it down into steps that we're gonna have to solve. So the first step is to sketch the force diagram for the object and list all the forces. So in this case, the car experiences two forces. And the first force is the gravitation force, or Fg, as shown down here, that always faces the center of the Earth. And the second force that we have is the normal force, that will always be perpendicular to the surface that the object will be traveling on. So for the next step, we'll need to define a coordination system for further force analysis. There are usually two ways of defining the coordination system in physics. One way is the horizontal-vertical coordination system, and the other commonly used way is the parallel-perpendicular coordination system. So the best coordination system in physics always depends on the motion of the object. In our case, the car is doing circular motion on a banked curve, and therefore there is no motion on the vertical direction. So by using the horizontal vertical coordination system, the sum of forces on the y-axis is equal to 0, and the sum of forces on the x-axis is the centripetal force, which is what we would like to find out and use to solve the problem. So as a result, the horizontal vertical coordination system is most appropriate for this problem. So for the next step, we'll need to break the normal force to its x and y components. And the reason we break down the normal force into its components and not the force of gravity is because when we define the axis, the gravity force is specifically on the y-axis. However, the normal force is neither on the y-axis nor the x-axis. So what we're going to do here is we're going to translate the theta to over here, and using our trigonometric knowledge of sine and cosine, we are going to separate the components of the normal force into Fn sine theta over here and Fn cosine theta over here. And in later steps, this is going to be very important to solving the rest of this problem. Now, the next step is arguably one of the most important steps to solving any physics problem, and it is to list all the known and unknown variables and associated equations in both the x and y directions. So if we were to do this on this problem, we are given that mass is equal to 3,500 pounds, radius equals 120 meters, and the angle denoted theta over here with respect to the horizontal is equal to 6 degrees. Now, from the free body diagram, we can therefore conclude that the y direction formula will look a little something like this. This is because gravity equals Fg, and Fg is equal to mg, where m is the mass and g is the gravitational constant. And from the free body diagram, we can draw the conclusion that mg is equal to the y component of the normal force, or Fn cosine theta, as shown previously. So now we go to the equations of the x direction. First off, we have the x direction formula. Fc equals Fn sine theta. Fn sine theta is the x component of the normal force, and that is equal to Fc, or the centripetal force, and what we need to solve. So the second equation is a general equation for the centripetal force, which is equal to mv squared over r, in which m is the mass, v is velocity, and r is the radius. So now we can look at what we don't know. And what we don't know is v, and v is velocity. And using all of the information given, we are going to solve v. So finally, we are now going to solve the problem. Recall from the previous step that the y direction formula is Fn cosine theta equals mg. And if we divide cosine theta on both sides of the equation, we will end up with Fn is equal to mg over cosine theta. Now also recall from the previous step that the x direction formulas, the first one is Fc equals Fn sine theta, and the second equation is Fc equals mv squared over r. So if we were to take the two equations from the x direction and the one equation from the y direction and merge them all in together, we would end up with Fc equals mg sine theta over cosine theta, which is equal to mv squared over r. Now, mv squared over r is the standard formula for centripetal force. So the left side of the equation, mg sine theta over cosine theta, can be derived from the first equation of the x direction and the equation of the y direction. So since we have an Fn in this side of the equation, we're going to take the Fn from the y direction of the equation, and we're going to take that formula and put it right in the x direction formula. So therefore, Fc would be equal to mg over cosine theta times sine theta, which is equal to mg sine theta over cosine theta. So from this equation over here, we can cancel out an m on both sides. And if we were to multiply r on both sides of the equation, we would get v squared equals gr sine theta over cosine theta. Now recall from trigonometry that sine theta over cosine theta is equal to tan theta, which is where we would get this equation. Now if we were to take the square root of both sides to isolate velocity, we would get v equals the square root of g times r times tan theta. Now, you know the value of g, you know the value of r, you know the value of theta, and therefore you know the value of tan theta. So the value of g is the standard 9.81, and the value of r given in the problem was 120. And the value of theta given in the problem was 6 degrees. So therefore, tan theta is equal to tan of 6 degrees. So now if you plug this into a calculator, you will get the value of 11.1 with the units of meters per second. Now if we were to express this value in miles per hour, we would get 24.9 miles per hour. So thank you guys all for watching, and I'll see you later.